Okay, this video is, can EMF have beneficial effects? And the answer is yes. It'll usually be used in a pulse form, so they'll call it pulsed electromagnetic field, and that's abbreviated PEMF. It's used in spine surgery for increasing the rate of bone growth when you want to do a posterior bony fusion, for example. Let's say in the lumbar spine. It can be used for fusion type surgeries in the cervical spine. And then here is it used in treatment of animals. The reason why treatment of animal studies are of interest is usually there's not much money involved and there's not much bias. But the point I'll make here is that it's used for a surprisingly large number of treatments with animals. So let's say, for example, and by the way, too, they talk about the same mechanisms that we talked about earlier in the previous lecture. Electromagnetic fields, they will, at the types used for cell phones, for Wi-Fi, for Bluetooth, they will open up voltage-gated calcium channels, allowing increased calcium to flow into the cytoplasm, and that activates a bunch of secondary pathways. Classically, you'll hear about it activating something called the calmodulin enzyme pathway, and these are ways to amplify the effect of an initial binding chemical. Okay, so what are some of the other things it's used for? Well, we know nitric oxide, when it runs its good pathway, is a vasodilator to increase blood flow, so that can be helpful for healing a wound, for treating a site that's in pain. Because if you have pain, a lot of times pain means the nerve is ischemic, lacking oxygen to function normally. So if you vasodilate, you get more blood supply to the nerve, more energy in the form of glucose and more oxygen. It can produce more energy, and often the nerve will hurt less. So healing wounds and getting bone to grow are sort of like the big two. For example, you could have a chronic non-union fracture, and increasing the rate of bone growth will potentially get it to heal. But the point I wanted to make was, here is animal research. And by the way, there's tons and tons of studies that show that it opens up voltage gauge channels. But I just wanted to make the point. In animal studies, you clearly show that highly controlled electromagnetic fields can increase healing, increase bone growth, improve wound healing, decrease pain in the nerve. And that's all relevant because there are definite, very significant physiologic effects, okay? And this is well known. And that becomes relevant because when you start talking about the harmful effects, there's all kinds of attempts on the part of industry to deny that they even exist, but they're well known. It's like it's not some mystery. Okay, and then here's just a diagram. We saw this before, but basically the electromagnetic field, either coming from the cell tower, from the cell phone, from the laptop, from the Wi-Fi router, from the smart meter, or from these other so-called smart devices in the home, open up voltage-gated calcium channels. That increases calcium in the cytoplasm of the cell. It activates secondary enzymes, in particular calmodulin, calcium modulated enzyme. Okay, that'll activate endothelial nitric oxide synthase and neuronal nitric oxide synthase. These are called the constitutive ones, meaning that they're only activated when there's increased cytoplasmic calcium. The other one, iNOS, inducible nitric oxide synthase, can be activated in a little bit different ways. But anyways, the so-called good pathway, and this really is the good stuff of increased nitric oxide, is when it has a vasodilator effect to improve blood supply to an area that benefits from improved blood supply, like coupled to increased neuronal activity or towards an attempt to heal, for example. But you can also run a bad pathway when there's excessive production of nitric oxide, especially when you're running on the other type of nitric oxide synthase, the inducible one, in the setting of an infection or inflammation. But here again, you can uncouple nitric oxide synthase and generate these superoxide anions. That's a free radical of oxygen, and the relevance is that will combine with nitric oxide to make peroxynitrite. So what I'm basically sort of saying here is, in the vast majority of situations that we think about in a normal context, what Dr. Esselstyn said is true, and it's good. You want more nitric oxide being produced by your arterial lining cells, your endothelium, to keep your arteries open so you don't die of the most common things, which is lack of blood supply to the brain, strokes, cognitive decline, or to the heart, myocardial infarction, congestive heart failure, atrial fibrillation, and all that stuff. But when there's abnormal excessive elevation of nitric oxide leading to production of, or uncoupling of nitric oxide synthase, leading to this peroxynitrite, then you start to run all the bad pathways that damage your mitochondria, damage your DNA, and cause oxidative stress. Okay, that's it for this one. I hope that was of interest. And it's I'm sort of building the foundation and then go into more interesting complex aspects of nitric oxide and peroxynitrite metabolism.